All right, here we go. Let's predict that salary with the SVR machine learning model. All right, so this time it's not going to be as easy as previously because we'll have to do some inverse transformation. I asked you to try to do it yourself, and now we're about to implement the solution together. All right, so let's do this. Let's start by creating a new code cell. And according to you now, what is the first step we have to do? You know, it's very natural. Indeed, we want to predict a new result, so the natural idea that comes to mind is to call the predict method, from our SVR regressor object here. So let's do this. Let's first call, the regressor itself, because that's from this object that you have to call the predict method. And inside the parenthesis, you know what we have to input. We have to input, of course, that position level of 6.5, right? Because this person we want to hire had a region manager position, but after a couple of years, so we consider it to be 6.5. And remember that this position level has to be in a 2D array, so we have to add here a double pair of square brackets and inside input 6.5. So that was the original format, expected by the predict method of our previous machine learning models, including polynomial regression, okay? But as I told you, it's not that easy here because we did a lot of feature scaling and transformations on everything, the matrix of features x and the dependent variable vector y. So here we have to do some extra things. All right, so first thing, well, since we actually trained the SVR model on x and y, which were both scaled with two different scalars, x was scaled by SCx, I can show this to you again. X was scaled by SCx and y was scaled by SCy. And so the consequence of this is that when you use the predict method on an observation, well, that observation has to be on the same scale as the values of your matrix of features on which your model was trained. So here, the first thing we have to do is apply the transformation, apply the scaling to that particular value. And how do we do this? Well, that's very easy. We have to call our scalar object for x, SCx, for the matrix of features x, and then from this object apply the transform method, which will exactly feature scale this particular value. Put this particular value in the same scale that was applied to the whole matrix of features x. All right, so let's do this. That's the first thing we have to do here. We have to call our SC underscore x scalar object, for the matrix of features x, from which we're going to call the transform method, thank you Google Colab, which will take as input exactly this 2D array containing the single value 6.5. All right, I have to add a new one here, and there you go. So that's the first thing you had to do to make sure that your value here inside the predict method is scaled on the same scale that was used to scale the whole matrix of features x. All right, so that's the first thing, and therefore this will return your predicted salary, but in the scale that was applied to y. The scaling that resulted from applying that second scalar object on the dependent variable vector y. And therefore, instead of, getting here a salary around, let's say 160K, we will get a salary around this range of values. All right, and that's absolutely not what we want. It is still correct, but of course what we have to do now is reverse the scaling of y, and more specifically of that prediction, of that predicted salary, in order to get the original scale of that prediction. And that's where you have to use this new method that can reverse the scaling, and which is called, I hope you found it on the internet or any documentation, this method is called the inverse transform method. And that's exactly what we have to apply here to indeed reverse the scaling to go back to the original scale of y, and therefore to go back to the original scale of that predicted salary. All right, so let's do this. In order to apply that inverse transform method, well, remember that any method has to be called from an object, and make sure to understand which object we have to call here. That's of course SCy, because we want to reverse the scaling that was used to transform the dependent variable vector y. So here we have to call SC underscore y, from which we're going to call that inverse transform method, thank you again Google Colab, which will take as input this whole prediction of the salary of the position level 6.5. And there you go, my friends. Now you have your prediction in the right scale. You want to check it out? Let's do this. We don't have to do a print here because this will return directly the prediction. I hope I didn't make any mistake with all these transform and inverse transform method and now all these parentheses, as you can see. But let's see. I just followed some logic here. And so now, if you're ready, well, let's execute our two cells here. First, this cell to indeed build and train the SVR model. So let's do this. And there we go. We get in the output the SVR model with all the parameters that were chosen. And we actually kept the default value for most of them except that kernel parameter, for which we chose indeed the radial basis function kernel. And now, time to get the final prediction. The predicted salary for that position level 6.5, of course, from our SVR model. And to do this, we simply need to execute the cell to figure out that the predicted salary is in fact $170,000 per year. So that's once again a prediction that seems to make a lot of sense, based on what this person mentioned as a previous salary. I remind that in our little story, this person mentioned to have a 160K salary in the previous company characterized by this data. So not only it is very close, but also our predicted salary is higher than the requested salary. So that's all good for our negotiation. And to compare with our previous model, the polynomial regression model, well, remember that we had a 158K predicted salary and now we have a 170K. So anyway, both these models return a prediction that is indeed close to what would be the real salary of that position level number 6.5. And so once again, that shows that the SVR model is really well adapted to this data set because indeed it can handle these nonlinear correlations between the position levels and the salaries. And we're going to see that much better in the visualization, because that's our next step, visualizing the SVR results in low resolution and high resolution. So that's what we'll do in this last tutorial. But now I really want to say congratulations because you now know how to handle the not only transformations but also inverse transformations, and you can now return a prediction when some feature scaling was applied on both the matrix of features x and the dependent variable vector y. It's really good that you know how to do this because indeed in your future datasets and your future ML projects you will definitely encounter this situation. So I'm really happy for you that you now have this extra tool in your machine learning toolkit. And now let's finish with the last exciting tutorial where we're going to visualize the results. So as soon as you're ready, let's observe the regression curve of the SVR model. And until then, enjoy machine learning.